radicand's position, which is within the integrand's position, I do think we have a difference of two squares. Excuse me. Unless there's a quick and easy use of I can apply, or I recognize an antiderivative was in the integrand position, if I see either sum or difference of two squares, I instinctively think about a trigonometric substitution. And since I do have a difference of two squares in radicand's position, let's give it a shot. Notice how this is a very backwards type substitution. I'm allowing x, the variable I already have, to be in terms of a whole new variable, actually embedded in the argument of a trigonometric function. Why are you laughing?
Because it's sine.
Yeah.
Oh, I made a mistake. Actually, yeah, I use tangents when it comes to sums of squares. My apologies. I really meant this.
No.
So, what do you mean no?
It should be sine.
Why?
Because secant of theta is going to be x squared minus something.
You mean it would be nice to have secant squared minus something.
Yeah.
Now, I agree with that. I don't think secant's going to work either because forget about the 64. Forget about the 8. When it comes to 1 minus secant squared of theta, I think by one of my Pythagorean identities is just not very useful. I think the appropriate choice here, since I've got something of the form a squared minus x squared, I think the best choice would to allow x to be nothing more than my a times the sine of theta, although I confess, not that I mentioned this in class, cosine would work just as well. Now, paying the consequence of my actions, I think that does imply the relationship between dx and d theta is as such. Now let's commit to this. I think this integral now becomes nothing more than the integral of, tell me if I'm skipping too much. Look what's above my black brace. Underneath the squared symbol, I get a 64 minus 64 sine squared of theta. I'll pull out the 64 from those two terms and then continue to pull the 64 out of the squared symbol. Let's talk about what's left over. What's left over that I had not written is the square root of 1 minus sine squared of theta. But that's the same thing as square root of, instead of two terms, one term, namely cosine squared of theta. But the square root of cosine squared of theta is merely cosine of theta. I'm nervous. It should be absolute values, but I discussed why we don't need the absolute values yesterday in class. I'll do it again if you like. And so I guess I've got my cosine of theta, d theta. Are you happy? That was an honest question. Are you
No,
happy?
no.
Why not?
Because it's going to be, let's see, 8 cosine of theta times 8 cosine of theta d
You guys,
theta.
did you see that? I think what you see above this brace is being rewritten this way. But I just can't magically write dx as d theta, can I? I'm not trying to annoy you. I'm just trying to show you some common mistakes I see. All right, I'll backtrack. I blew it. I think more correctly, another name for d theta is actually right down here. It just has to be another factor of a cosine of theta. Or shall I say, I have sitting in front of me, is that a 64 integral of, is it cosine squared? All right, let's take a break. I did something. I committed to a trigonometric substitution, which I think was a good thing, because I think I significantly cleaned up what's in the radicand's position. It's just that, what the heck do I do next?
You change, yeah.
What trick stuff? What do you mean?
The 1 plus cosine 2 theta over 2.
Nice. It's sort of like one of my reduction identities in trigonometry. I can rewrite the cosine squared of theta as nothing more than 1 plus cosine of twice theta all over 2. So give me this. Now, I think the whole point in evoking that reduction identity back from trigonometry is that cheapers, I can fall asleep. In my deep, deep, deep REM sleep, I think I can evaluate this integral. I think it merely becomes a 32 theta minus, is that a 16, or should I be say plus 16 sine of 2 theta? As theta ranges from, there are no bounds, my apologies. I guess from I don't know where to I don't know where. Let's see. Now I need to have my constant because I've got it in front of indefinite. I don't know, you guys, I'm being honest with this question. Are you happy?
No.
Why not?
You have to put another substitute.
Do you have to?
Do you have to?
Yes.
See, I'm not sure. I don't know. I don't know if I really have to or not. I think it looks clean the way it is.
Well,
But I suppose you could use your double angle identity because some people would say mathematical etiquette. Had thetas along this way, rewrite it in terms of thetas. Yes, Reese?
This might sound like a stupid question, but when you take, why do you become 16 here? Because I know you took the
because I skip steps. Because what I really have is a 32 times, let's play. Anti-differentiating term by term. Doesn't that give me theta plus 1/2 sine 2 theta? Just because it was a backward substitution, or I shouldn't say backwards, it was a forward substitution, I just didn't write it down. I really meant to say u equals 2 theta, which means du is 2d theta, and I bring the 2 on the other side, there it is.
So something I noticed when I was doing the homework was when you do your right triangle at the end, the missing side is always going to be what's underneath the or what's underneath the radical.
I mentioned that yesterday in class with one of the first ones I did when it comes to a proper.
That's always the case, though? There's never
It
a...
better be.
Okay.
Something's wrong along the way.
Okay.
But you guys, in terms of theta, I'm happy with this. If my final answer is in terms of theta, I don't need to evoke a double angle identity. Well, admit, in this particular example, I got to go back even further than theta. The original variable is actually x. And if my original variable is actually in terms of x, that means I gotta somehow re-describe what's going on with this relationship. And I think the easiest way is with a pretty picture. And I think drawing a picture, tell me if I'm talking too much without writing. I think I need to address the issue of what's the pictorial representation of the mathematical statement? Sine of theta is x over 8. And here's a pictorial representation. If I embed theta in a right triangle, to say the sine of the angle is x over 8, doesn't that mean with my right triangle trigonometry that the ratio of the length of side opposite theta to the length of the hypotenuse is that ratio of x to 8? And Brad, like you're pointing out,
Yeah.
I think using my Pythagorean theorem, clearly the length of the other leg is this, which of course is something you saw somewhere within the integrand's position. And Brad, can I take it back a little bit?
Yeah.
It's not that what I said was wrong, it's just that sometimes if I have to complete the square in here, it might look different, but it'll be equivalent in the end. They'll be
Okay.
equivalent. Okay, you guys, I gotta figure this one out. This is 32 times the sine of. Sine inverse. Good, it's not sine of anything. I think it's the inverse sine of that x over 8. Plus 16 times, well, the sine of the angle, is that x over 8?
No.
I
You
don't
have to
think it
split
is.
that up.
I don't think it is, because I think that's not the angle in my picture. I think I'm in trouble. I think this time around, I have to go back in terms of rewriting the sine of 2 theta as an expression involving some trigonometric expressions evaluated on a single theta. This time around, since I'm backing up all the way to x, I have no choice. I've got to go back and invoke my double angle identity. Of course, they just roll off your tongue, don't they?
2 sine theta cosine.
Thank you very much. I was hoping you'd say that. And in this particular case, that gives me 32 inverse sine. You guys, can you just make my life easy? Do you mind if I just cancel now?
No.
Well, yeah, you do mind, because I can't cancel. I can't bring the 1 in.
Oh. The
Plus, is that a 32? And I have no idea what the rest is. The sine. Thank you. X over 8, you said. And then.
The square root of 64 minus x squared.
Gotcha.
Over 8.
So over 8.
And that ends up canceling x over.
Can you say that again? I'm sorry.
You can simplify to x over 2. The 8's.
My apologies. You're simplifying. I see it. So you're saying this is 32 inverse sine of x over 8 plus my, I agree with that 1/2 you said.
No, x over 2.
So same thing, 1/2 times x, whichever way you want to write it. Times square root of stuff. By the way, 64 is not the same as 16. I like it. Not much else I can do to clean it up. Is that okay? That's why I'm here. Yes.
How do you know to do the inverse sine to find that theta, the 32?
Good question. Notice how at this stage of the game, it's my mathematical responsibility to rewrite theta in terms of x. And so all I did was I went back to how I set up my substitution and said to myself, I can easily isolate theta. I'll divide both sides by 8 first. And then I will take the inverse sine of both sides. It's really because of my choice for the substitution for x in terms of theta. I think this says that theta is equivalent to the inverse sine of x over 8.
Would you use the hypotenuse was 8 because 8 was up the sine?
I think I knew the hypotenuse is 8 because, can I put an intermediate step? Let me slide this down. I knew that the 8 was the hypotenuse position because if I divide both sides by 8, you just relax and check out what this really says. Sine of theta has an alternative name. But if my sine can be represented as ratio of opposite over hypotenuse, I place that in the opposite sides position and that in the hypotenuse position. I was being that silly with my right triangle trigonometry. Come on, you guys attack me. Anything else here? All right. How about something like 53?
And I have one as well.
You got it. Ooh, 63 looks fun. X squared minus 8x plus 16? Over... I lost you guys. What number is this? 53? 9 plus 8x minus x squared. 9 plus 8x. Ah, shoot. What did I just say? Minus x squared. I'll raise to the 3/2. Sorry, I'm so slow.
This looks fun.
Oh, this looks like a blast. Any ideas?
Complete the square at the bottom.
Yeah, I'll agree to that.
Make complete the square at the bottom look like the derivative or the antiderivative at the top.
How?
I have no clue.
Anybody?
Can you factor the bottom?
I just tried. It doesn't. Actually, it
X
does.
squared minus 1.
Oh, you can cancel out with one term at the top.
It just doesn't help me much. David, I'm sorry.
If you factor the top,
I just did. It factors nicely. It just doesn't help.
burn it.
Okay, let's burn it. Let's get rid of it.
Scrap it.
And now I'm going to burn it in a very special way.
Of course.
I want a yes or no answer. Would it be nice to have that? I said, I want a yes or no answer. Would it be nice to have that?
Yes.
Why?
Because you can cancel out.
A bit of cancellation. I think that merely leaves me with an integral of, is that a negative 1 over 9 plus 8x minus x squared raised to the only positive power? Of course, you guys are wrong. I mean, I can't just magically wave my hands and say, oh, my 16 is the same thing as negative 9, but I could do this. I could add my funky little form of 0. The form of 0 I'm going to add upstairs is a minus 9 plus 9. There's my minus 9, and here's my plus 9. Which gives you this. Same thing. Oh, but you know what? Kind of like these two integrals in that I've only got a constant upstairs making some kind of substitution easier to handle, but what would the substitution be? All right, maybe I phrased that question poorly. Let me restate it. Does it appear that I can apply some kind of trigonometric substitution? Yeah, it appears to be such, doesn't it? After all, applying a trigonometric substitution because I see a squaring of x. Oh, actually, the x term's in the way. So what are you going to do about that?
You should factor it.
I can actually factor this. I just don't think it helps much.
Complete the square.
But I can complete the square on x. And then complete the square on x.
If we do that, lost me on the 25. Where'd that come from?
Think of
Equal
this.
sign.
Watch my red pen. I wanted a negative 9 in there, so I threw it in.
Yes.
Compensated.
Yes.
These three terms, with my arrows, were devoted to the numerator in the first integrand.
Gotcha.
Well, I don't know. Can you guys tell me how I'm going to complete the square on this? I said, can you guys tell me how I'm going to complete the square on this? just don't wanna play.
But you want to make that a 15 or 16 somehow?
Well, why don't
So-
you get rid of that negative? Or,
Plus 7 minus 7?
So you're saying this,
Yeah.
like that? No, I'm asking.
no,
Wouldn't it be plus 7 minus 7? So wouldn't that be like a negative 7?
So you're saying this, make this a negative 16?
Oh, no.
I'm just asking.
You would add the 7 to the 9 to make it a 16, and then subtract the 7 from the entire thing.
parentheses. No, yes.
Does that work?
I can put them in, but they'd be superfluous. Are you guys happy with that?
I don't know.
See, I'm not. Here's,
Just a quick question, we go back. We have a negative x squared, and you say you like to make it positive. Why don't we just make it positive? Switch on
very
sides.
nice. That's why I think you guys are struggling with the 16. So if you guys don't mind, before you complete the square, do this. Let me get rid of all this garbage. And in the denominator's position, and underneath the square root symbol, let me think of these three terms as the opposite of an x squared minus 8x. I'll stop. Yes? It disappeared because if you take a peek at how nice I divvied up that numerator, this thing right here really is the negative of this thing.
Okay.
And I got a bit of cancellation. It left me with a negative sign, but only left me with this denominator of the 1/2 power.
Gotcha.
That was the beauty behind slipping in that funky looking form of 1 in red, the funky looking form of 0 in red. But you guys, humor me. I didn't get rid of the 9. It's still there. But what would I add in here to complete the square? No tricks this time.
16.
Positive 16. But notice the net effect on the entire expression within the square root expression. Notice what I've really done to the entire radicand. If you remove parentheses, I've really added a negative 16 in there. So to compensate, I'll add a positive 16 as well. Do you guys see my point?
Because the negative
Deb, you don't like
distributes.
that.
No, I'm just trying to calculate still, sorry.
Okay, that's okay.
It's 10 steps behind.
And you put the positive because the negative distributes into the...
Exactly, and I want to undo that. Do you guys mind if I skip the next one? I think something similar is going to happen. And rewriting more concisely, I think that gives me the integral of a negative 1 over, okay, let's write everything out. Is it the square root of 25 minus a trinomial that is indeed equivalent to a perfect binomial square, namely 8, is that plus 4? I took my glasses off.
Then you make u-subs.
I will, but this time I won't slough off. I really will write the second integral. But playing exactly the same game in the second integral, isn't that going to be 25 over the same darn radicand?
Isn't it x minus 1?
Is it x minus 4?
Yeah.
You guys, that's my mistake. I'm sorry. You're right. Because the second term of the trinomial. It's just that with the second integral, I think all that's actually raised to the 3/2, I think, as I recall, not the 1/2.
Shouldn't your x minus 4 be squared?
It should be, like I said, the same thing over there. Oy, oy, oy. I want a yes or no answer. Is this going to be a piece of cake?
Pretty much.
Yeah, I think
Trick
so.
sort.
Because at this stage of the game, let's put on some special glasses. Let's think of x minus 4 as z. It's sort of like I got the difference of two squares, 25 minus z squared. Doesn't that just scream out at you that I should allow z to be equal to nothing more than 5 times the sine of theta? No tricks.
Is there any reason why we're calling it z?
Because I just wanted you to see this as a
Okay.
difference of two squares. I didn't write it as a z to the 9.
Okay.
Which I think means dx is related to d theta this way. Yes.
So when you're applying trig subs and you have something in the radical, under the radical symbol, that is 1 power above, so you have x cubed equals to 5 sine theta. That would not work.
No, because I wouldn't be able to invoke my Pythagorean identities and rewrite this radicand as a single term. I think that's the issue.
So you would have to figure another way to solve it. You wouldn't be able to apply a trig sub.
I agree with that. And so if I think in the radicand's position, this would be cute, I'd have to do something like, I don't know, something maybe to get rid of radicals. Actually, to get rid of radicals, I'd be rationalizing the expression. So why don't we give that a new name today in class? I'll give you a whole new technique, call it a rationalizing substitution. You're stealing my lecture. So can you guys help me with the substitution? The first integral, I've got, what's downstairs? What is the substitution? Downstairs.
25 minus 20.
Ooh, downstairs. Make the substitution.
Well, yeah, it'd be 25 minus 25 sine squared.
I was hoping to
Theta.
say nothing. Don't do the downstairs, just give me the answer to the integral. Just state the answer. I said.
Oh, it'll be 5 cosine over.
Oh, negative, okay, sorry.
Secant inverse.
Secant.
Sine, can I put a vowel?
5 theta. Inverse.
Inverse, jeepers, this is
I already
tough.
said that.
Oh, did you really? I'm sorry, I didn't hear it, Randall. That was Z over, I feel so long. My A, good.
Huh?
Did you guys agree? Didn't we talk about last time in class how the integral of this beast right here is equal to this beast? And we proved it? Well, I did, as I recall. What, as I recall?
Told us not to memorize it.
Well, true, it's just you used it so much last time in homework, now it's just natural. And he's got a good point.
I would
Remember
probably go through a bunch of steps before getting to that.
that? Yeah, but I went through them for you.
All right.
And so Brad, I need to shut you
Yeah.
down, and
Okay.
he's right. If you didn't remember this, who cares? You know, you just commit to the substitution. I promise you, it'll come right now. I'm just trying to skip a few steps. That's all. Anyway, I think for the next integral, you know what? I can't walk that fast. Maybe for the next one, I'll slow down and commit to my substitution. I think this gives me a plus. Can I pull the 25 out?
Yep.
Now this time, no tricks. I think downstairs, what I really have is, when I commit to the substitution, would this be a 25 minus 25 sine squared? But when I pull the 25 out, doesn't it give me this? And what's being raised to the 3/2 power is just 1 minus sine squared of theta. But 1 minus sine squared of theta is nasty, but it's two-term expression. How do I rewrite that as 1? Yeah, just as a cosine squared of theta. Oh shoot, I forgot my dx. But another name for dx is just simply 5 times the cosine of theta d theta. But that's equal to, oh, easy business. Plus, I have no idea what's left over. Can I just put the coefficients real quick? Instead of 25 times, I'll pull the 5 out from upstairs. But downstairs, let me cheat. The square root of 25 is, but 5 cubed is,
125.
of course, when you look at those coefficients on the outside, don't they completely cancel? I got lucky.
And then you got cosine cubed.
But I think on the inside, I got a 1 over,
Cosine cubed.
yeah, that's a cosine cube, but I got a cosine upstairs. So I
So
guess it gives me cosine
cosine
squared
squared.
downstairs. Oh shoot, that gives me a whole new question, which is this. Hold on a second.
Secant squared. Right.
Ah, you saw it already.
Yep.
Because I think what's in the radicand's position is nothing more than secant squared, but jeepers, you're deep REM sleep, and antiderivative for the secant squared is
Tangent of theta.
of theta, and here's all of it. Are we done?
We have to back substitute.
Yeah, we're not done. Shoot, mathematical etiquette, yet again, suggest. Since the original question was posed in terms of the variable x, I got to write my family answer in terms of x. So, let's play. Let's draw a pretty picture. And I think a pretty picture from here suggests that if I embed theta in a right triangle, to say that a sine is x minus 4 over 5 means a ratio. Opposite side to the hypotenuse is that ratio. Which means I've got the square root of the hypotenuse squared minus the other leg squared. Brad, I'm not picking on you. Remember you asked a question?
Yeah.
Is it always gonna be, you notice what would happen if I would just, for some reason, wanted to clean this mess up? Expand the binomial square, collect like terms. I know it doesn't look like what was originally, right here. It'll look more like what's over there.
Okay.
And it's the same thing. And I maintain in the end, I'll back substitute. So I've got the inverse sine of x minus 5, all over 5, plus a tangent of that angle. But jeepers, you guys, a tangent of the angle is nothing more than the ratio of x minus 4 to the square root. Sorry, I can't do it in my head. Is it 9 plus 8x? Minus x squared. What do you think?
Beautiful.
Where did the x minus 5 come from? Yeah, the sine versus the x minus 4.
Pure
Yes.
Harry Potter mathematics. So therefore, magic becomes 5. I like 5s.
Sounds a nice odd number.
It's a nice prime number. Thank you. You guys, is that okay in terms of the process, though, even though I can't keep track of my numbers? David, did you see that another one?
Yes, this guy right here. It's from Stewart.
It's a 30.
Yeah.
Well, right there. Sin t. Oh, I just got my bounds. Oh, and I forgot the square root symbol. So here, and can you just double check real quick? Is that what was there?
Yes.
Well, everybody, immediately using my Pythagorean identity, can't I just simply do this?
Not your Pythagorean identity.
What do you mean?
It would be 1 minus sine squared of t if
Isn't
it was
that
your
like
Pythagorean identity.
Yeah, do you guys see his
Hyperbola?
point? I can't do this.
Well,
Because I think Pythagorean identity was to have subtraction if they're not addition. I think I'm way wrong. Yes, sir.
I was wondering on the, on 53, how did sines of inverse sine suddenly become positive?
God, I'm just messing up in terms of copying my own writing. Do you guys, before I go back over here, do you see his point? Do you see when I continue writing, my 4s became 5s, but my negative signs just magically disappeared? All right, so you can take a point off. Thank you. But you guys see I'm wrong over here? Just because I had the sum of 2 squares doesn't necessarily mean my Pythagorean identities help me. I'm wrong. So, I guess the next best thing is to do, I guess.
Couldn't you just take the sine squared and then turn it into 1 minus cosine squared and then add it, and then it becomes 2 plus?
You know, I can. It just doesn't help. I see what you're doing in your head. You're getting a 2 minus sine squared of theta.
And then can you do the shrink stuff? Oh, no, wait.
It just doesn't help.
Okay, sorry.
Any other ideas? I think that'd be the easiest thing to do. So everybody, notice how what you see upstairs is immediately the derivative of at least a small component was downstairs. As a matter of fact, I think if I allow u to be nothing more than the sine of t, du is already in the integrand's position as a factor, and therefore I think that might be the appropriate, or that will be the appropriate use of and I think all I'm really left with at this point is 0 to pi halves. Actually, I misspoke, didn't I? I really did. If t is equal to 0, u is
0.
0. If t is pi halves,
1.
u is 1. Thank you. I'm left with this. What would you do next? That's an honest question. What would you do next?
That u equal to tangent of theta.
All right, I'll do it. And if I now come in and make a second substitution, namely u being equal to the tangent of, I don't know, you said theta, then du certainly is going to be secant squared of theta d theta. And when I apply the substitution, I get the integral of a 1 over square root of 1 plus tangent squared of theta. Let's think this is 1 over the square root of secant squared of theta. But the square root of secant squared of theta, as long as theta lives in an appropriate region, is just going to be the secant of theta. Oh, but now I got to multiply by another name for du, but that would just simply be secant squared d theta. But that merely leaves me with the integral of the secant of theta d theta. Ah, but shoot, we recognize that as being nothing more than
Negative natural
I agree with that. So where are we on the happy scale?
We're in bounds.
We're in bounds, we're in bounds. Oh, my apologies, the bounds. I thought you were being funny about that. You're right, I messed up with the bounds, but it's okay. Because I think if u is equal to 0, then theta is going to have to be this. But I think if u is equal to 1, theta is going to have to be this. So, from here to here. And then, I really did forget, I had a definite one. And then, from here to, was it pi quarters? But then evaluating, I said evaluating.
Root 2 plus 1.
Nice. Did anybody answer this question differently? Anybody?
I don't think anybody did that out of the Stewart book.
What's that?
It was out of the Stewart book.
Oh, then particularly out of the Stewart book, would you do it differently? Could you do it differently?
Oh, well, I didn't, but now I see that it resembles a hyperbolic,
So you're saying is I did way too much work. From here, you can just immediately state that you got an inverse hyperbolic. I agree.
wait, I didn't see that.
From here, you can state that it's an inverse hyperbolic,
Oh,
but you
oh,
defined or you found the inverse hyperbolic could be described in terms of natural laws.
Okay.
Get the same answer, just a different way of looking at it. Is that okay, everyone? Well, if there are no more questions,